Ecological Research Center in the URB, Universitat Rovira i Virgili. It is an absolute pleasure to have today Professor Richard Tol, who is going to do the keynote speaker. It's also a pleasure for me to present Professor Tol, but to be honest, I have a very difficult job because in just few minutes it's all impossible to summarize what the CV of Professor Tol, but I will try to do so. Professor Richard Tol is professor at the Department of Economics of the University of Sussex and the professor of the Economics of Climate Change at the Institute for Environmental Studies at the Brugge University of Amsterdam. Universitat Autònoma of Amsterdam. He is also a member of the Academia Europea. In the past, he has been at the University of Victoria, British Columbia, University College of London and Princeton University doing research stays. Professor Tol is ranked among the top 100 economists in the world. Specifically, this month, he is in the position 92 according to REPEC database. According to Google Scholar, his age index this morning was 122, with a number of citations of 55,887. This is the information of just 2 hours. His research interests include economics of energy, environment and climate. He is also interested in tourism and scientometrics. He is the editor-in-chief of Energy Economics. This is an information that everybody can get from the internet, but allow me to say a few words about my personal experience with Professor Richard Tol. By the summer of 2010, I sent him an email introducing myself and asking for a period of research at the Center of Economic and Social Research Institute in Dublin, where he was by then. I got an almost instant answer from him, accepting my offer and welcoming at the Institute in Dublin. During my research stay in 2011, I became one of his more than 100 co-authors in the world. Probably I was one of the first women. No, not the first. Okay, not the first. But probably the first Spanish?
No.
No? Well, the first Catalan, let's say.
That may be true.
Not maybe true?
That may be true.
Maybe true. Okay, okay. So one thing true. Since then, Professor Tol has answered all my requests for my PhD students, reference letters, support letters, and everything. So he always is very receptive with all the requests, and I'm really grateful to him. Finally, I would also like to thank Professor Tol for coming to the URB. This is not the first visit, it's just the second. He was in 2013 in the School of Engineering for a thesis committee. He also was the keynote speaker of a workshop that was online during the lockdown. Professor Tol, thank you so much for being here, and thank you one more time for accepting my invitation. So the floor is yours.
Thank you. It's an honor and pleasure to be here. As Maria said, one of the things that I do is in scientometrics, and one of the papers that we recently, or that we're currently working on, is about the treatment of female economists by their fellow economists. And the picture, as you probably know, is not at all pretty. And I corrected you there because I strongly disagree with that, and I've always encouraged female economists. That is why I corrected you. But I'm not going to talk about that aspect of my research agenda. Instead, I'm going to talk about the total cost of carbon, which is another topic that is dear to my heart. I'm going to show you some old things, but mostly fairly new things, and mostly things that I hope interest you. Just to start off, the social cost of carbon is the damage done by emitting 1 additional ton of carbon dioxide. It's also the benefit of reducing your emissions by 1 ton, right? If you estimate the social cost of carbon along the optimal emission trajectory, then it is what is commonly known as the Pigou tax. It is that tax that internalizes the externality and restores efficiency. I think it's actually wrong to call it the Pigou tax because while Pigou proposed a tax like this, Pigou's understanding of what is an externality is completely different from our understanding of what is an externality, and it's really Bator who proposed this thing that we now call the Pigou tax. Technically the social cost of carbon is defined as you see in this equation here. That is, what we do is we emit CO2 or some other greenhouse gas at time 0, or the point of evaluation, right? And then what we're interested in is how that changes human welfare in all future periods. So that is what the T does here, so we need to discount this whole thing. Of course we affect not just one person, but we affect the entire world, so we need to aggregate over regions as well. And then it is the future, so it is uncertain, so we also need to aggregate over states of the world, alternative ways in which the future may unfold. And then if you take this triple sum, then you have the social cost of carbon measured in utils, which is not particularly useful if you want to impose a carbon tax, because a carbon tax comes in dollars or in euros or something. So then you need to reconvert it back to money by taking the inverse of the first partial derivative of utility to consumption at time 0. So this is the standard definition of the social cost of carbon. And this seems a trivial thing to say, but actually I'm going to talk about this at some length. You may wonder about this thing here. This is just a shorthand, right? The first partial derivative of future utility to today's emissions is actually depends on a very long cause-effect chain, right? So utility is here assumed to be a function of consumption, whatever that may be, and some indicator of the climate. Consumption, of course, the economy is a conservative system, right? Consumption depends on what happened in the previous period. There may also be a direct effect, so we have sort of direct effects of climate change on utility. If species go extinct, that sort of stuff, loss of diversity, that directly affects our utility. But it may also affect economic output in terms of crops not growing so well, or bridges being washed away by floods and those sort of things, right? This thing is here as well, and of course the economy depends on the economy in the year before. Then the temperature depends on the atmospheric concentration of greenhouse gases, but again it's a conservative system. It also depends on the temperature of the atmosphere in the previous period, and what is going on in the ocean temperature in the previous period, which in turn depends on the ocean temperature in the previous period, and the temperature of the atmosphere in the previous period, right? So you have this coupled differential equation here. Then the concentration of CO2 in the atmosphere depends on the concentration in the previous period, depends on emissions, of course, in the previous period, but the concentration of CO2 is also affected by the temperature of the atmosphere and the temperature of the ocean. And then finally the emissions depend obviously on the state of the economy, but also depends on the temperature itself, right? If it's warmer, you burn more coal to make electricity to run your air conditioning, right? So this shorthand that I showed you, and I'm actually not going to talk about this stuff for much longer. This shorthand that I showed you is really a shorthand for a very complex dynamic system. Now there are some jokers who publish in Econometrica who think they can solve this analytically, But you can only do that by simplifying the system so much that it doesn't resemble the way the Earth system works anymore. Then you can come up with an analytical expression for this. If you want to respect the physics of the system and the biology of the system and the chemistry of the system, then you have to solve this numerically, right? And most of the results that I'm going to show are actually based on numerical representations of this fairly long and complex chain of events, right? So this is the definition. This is a very complex thing, right? Even though you can write it in a very simple way, it is a very complex thing. So the first question you may have is, how large is this number? Essentially the question is, what is the tax that we should put on our greenhouse gas emissions? Now, because the social cost of carbon is essentially the PIGU tax, it is essentially the number that goes into any cost-benefit analysis of climate policy, there is a large literature on this. It's intellectually stimulating because it's such a complex thing, but it's also very policy relevant. Definitely in the United States, there is a mandate, actually going back to Ronald Reagan, that for everything the federal government does, there has to be a cost-benefit analysis, and everything that touches on greenhouse gas emissions, there has to be a cost-benefit analysis, and therefore it has to be a social cost of carbon. So it's directly relevant to US climate policy. The European Union also has this obligation, but typically skirts this. But definitely in the UK, they also do a lot of cost-benefit analysis, and increasingly also in countries in Asia, they want to know what is the social cost of carbon. So it's intellectually stimulating to estimate this, because Nordhaus won the Nobel Prize. You can publish well with new estimates of the social cost of carbon, showing that this Nobel Prize was wrong, right? Or this Nobel Prize winner was wrong, and it's policy relevant. So you should not be surprised that there are a lot of estimates out there. Now, this is an incomplete account. This is from a paper that I published about a year ago. Did the work a little bit earlier, of course. And then I counted 323 papers. I miscounted. I think there's more like 450 now. But they are not in the database yet. So there's 323 papers that I'm going to talk about with a total of 12,287 estimates, right? And then if you just put everything to a common year and to a common dollar, then the following histogram emerges. This is the PDF of the social cost of carbon. And what you see is that there are a few people, a few estimates out there that say, well, the social cost of carbon really is a social benefit, that really we should be subsidizing CO2 emissions, as many countries still do, right? But that is a very small minority. This has to do with CO2 fertilization. If there's more CO2 in the atmosphere, the plants grow better and are more water efficient. It has to do with reduction in the costs of keeping your house warm in winter and those sort of things. But this is really, really a minority. Most people say that the social cost of carbon really is a cost. The mode is actually fairly low. It's around $30, $40. Yeah, $30, $40. But then the tail, and that is terribly important, it just keeps going, right? There is it's a very skewed distribution, and it's skewed in the wrong way, in the sense that negative surprises are actually much more likely than positive surprises of equal but opposite magnitude, right? So the right tail actually grows and grows and goes further. I actually cut off the right tail here. The maximum estimate that you find in the literature is around $10 million per ton of carbon, which I understand the numerical reasons why that happens in the model. That number is too high, right? If you would impose such a carbon tax, then actually if you impose a carbon tax that is more than 7,500, we would all be paying everything we own in carbon taxes at world average, right? So it would exceed the willingness to pay, the ability to pay. I see the social cost of carbon as our willingness to pay to reduce greenhouse gases, and the willingness to pay should not exceed the ability to pay, I think. Some people disagree with me. But this fat right tail is a real thing, right? And it's terribly important. So even though the mode is fairly modest, the expectation lies more towards the 200, perhaps a little bit higher than that, right? And that is because of that fat right tail. So this is, if you look at all the literature that is out there. This has changed over time. This is the same data set, but now plotted against the year of publication, not necessarily the year the research was done. We started off in 1980 and 1982 with two fairly high estimates, and then things came down, were fairly unsettled for a while. But since the year 2000, it's sort of under control how to estimate. Some of the stuff that you read earlier, people make really strange assumptions. But from the year 2000 or so onwards, people know how to estimate the social cost of carbon, know how to run an integrated assessment model. And what we've seen since then is an upward trend in the estimates. Some of this is because people are getting more concerned about climate change. Most of this is because we see a shift in the ethical parameters that go into these estimates, and I'll talk about those at length, right? But this is what is in this particular literature, right? Now, how soft or how hard are these estimates? So, social cost of carbon, here it's its definition again, depends on a large number of assumptions, right? I gave you the cause-effect chain, so it depends on how does the carbon cycle works. It depends on how does the atmosphere, how does the climate respond to changes in the atmospheric concentration, right? That is the physical science and the chemical science of the atmosphere. It interacts with the ocean, and how fast is that interaction? It interacts with ice sheets, and how rapidly can that change? And I mean, people think of ice sheets in terms of there's a lot of ice there, and if it would melt, then sea level would rise. That is true, but if you think of Greenland, Greenland is also actually a very big ice mountain, right? And if Greenland would melt completely, it would not just be that all that ice would end up as water in the ocean and endanger our coasts. It would also take away a very big mountain range and therefore completely change the winds in the northern hemisphere, right? And for that reason also completely change our climate. So there's very complex things going on. Now those are sort of positive questions, natural science questions, where you can say, well, we can find an objective answer to these things, or perhaps an intersubjective answer. And if smart people work hard enough on this problem, we can sort of like reach an agreement about how these things work and what the parameters are, right? It's very complex, very uncertain, but you can sort of imagine that there is some sort of established PDF about all the relative parameters and all the relative processes, right? There's also a number of normative parameters here, right? We have a utility function, and that has a certain shape. And for those of you who are in behavioral economics or in welfare economics, you know that there is no such thing as a utility function that everybody agrees on, right? We have aggregation over the uncertainty space. And again, there's a wide range of opinions about that. We have aggregation over time. So the discount rate plays a big role. Actually, I put in an exponential discount factor in here, right? And there may be people in the audience who are dead against exponential discounting, right? So there's a large number of assumptions that go into this. Some of which are positive, it's about how the world works. And some of it are normative, it is about how we define and evaluate welfare, right? So let me dig into the sensitivity of the social cost of carbon to some of these things. Obviously, I can't do all within the time that is allotted to me, and it would send you to sleep, frankly, if I would take you through all of them. But I'll take you through some. And I'm going to start by looking at the impacts of climate change on total welfare, and see what it does to the social cost of carbon. So I have more than 12,000 estimates, right? So I can do proper statistical analysis with that. And what I do here is I simply run a quantile regression of the social cost of carbon as reported on the assumptions that go into those estimates, right? And I'm here showing the results of one of those parameters that goes into that, and that is how much damage would 2.5 degrees of warming do, right? So that is on the vertical axis here. If I increase the benchmark damage by 1% of income, how much does the social cost of carbon change in dollars per ton of carbon? So that is the unit that you're looking at. And then we're looking at it across the distribution of the social cost of carbon, right? What you see is that if you assume that there's more damage, if the total is larger, then the marginal is larger as well. But it's a social cost, so it's a negative, right? But that is just a matter of definition, right? So if you assume more damage, then the marginal also goes up. No surprises here. Also no surprise, actually you see not so much action in the left tail of the social cost of carbon, but you see fairly big action in the right tail of the social cost of carbon, right? So if you assume more damage, then what you have is that the distribution shifts to the, I think, to the left, and it becomes wider, and particularly it actually shifts to the right, right? And the fat right tail actually becomes a lot fatter, right? That is essentially the pattern that you see here. And this should be no surprise to you. This is just a quantification of at least my prior. So then the question is, of course, what should we assume about the total impact of climate change? There's very few people who were here yesterday when I showed this graph as well. So let me take you through this. That's the right assumption, right? I see a few familiar faces, but not a great many. This is from another meta-analysis, now a meta-analysis on the total cost, the total impact of climate change. It's a confusing graph and a complicated one. On the horizontal axis, we're looking at changes in the global mean surface air temperature since pre-industrial times. We're now at 1.1, 1.2, maybe 1.3 degrees warming. Not because we think that global mean surface air temperature is all that matters, but this is just an index of the severity of climate change, right? On the vertical axis, we're looking at a Higgs equivalent variation. That is 2.5 degrees of warming would make the average person feel as if she had lost 2% of her income. Right? That is how to read this graph. There's 40 papers, as far as I know, that published estimates of the total impact of climate change, and total 72 estimates in those 40 papers. And you see 69 of those on this graph. There's 3 more in the next room that I sort of cut up. And what you see is what you would expect, or what you should expect. And that is, this is a hard question. What will climate change do to human welfare? Because the sort of climate change that we are projecting for this century is unprecedented since the evolution of Homo sapiens. It's not something that we have ever experienced as a species. And definitely not something that we have experienced in an industrial or post-industrial economy, right? This is just not something that we're used to. So there's no data really to go on. It's all extrapolation. And it's a really hard question because climate change affects agriculture, it affects energy use, it affects tourism, it affects transport, it affects construction, it affects labor productivity, it affects human health, it affects ecosystems and unmanaged ecosystems, and so on and so forth, right? So there is this long, long list of impacts. Some of it are relatively easy to monetize, some of it are actually very difficult to put a monetary value on, right? And not for the economy of 2024 that we sort of understand what is going on at the moment, no, for the economy of 2085, right? So this is a hard question, and therefore it should come as no surprise that different authors come with very different estimates of this. You see some positive impacts. This is reduced winter heating, reduced winter deaths. This is CO2 fertilization. I talked about these things. By and large, and these are essentially sunk benefits, right? Because of the conservative, they actually are beyond the point of positive impacts already. The impacts that are yet to come are by and large negative, right? The gray curve that you see here is the Bayesian average of 7 popular models in the literature that I fitted to this data, and then I just took the weighted average of those. That's the gray curve that you see here. Similar thing for its confidence interval. This is a bit wide, but again asymmetric, right? If you use this curve to scale everything to 2.5 degrees of warming, the benchmark, and it's a benchmark because we have most evidence for this, the following histogram emerges. So we have some estimates that say, well, climate change will be good for us. I wouldn't put too much stock on them. We have this, again, ugly tail, and it's a pretty thick tail. And then we actually have this mode that is very pronounced, that sort of suggests, well, 2.5 degrees of warming would make us feel as if we basically lost a year of economic growth, right? So this is what the literature on the total impact of climate change tells us we should be putting into our estimates of the social cost of carbon. And the blue is still the blue. Yeah. In red, we're looking at what does the literature on the social cost of carbon assume that this benchmark damage is. And you don't need a fancy statistical test to tell you that the red distribution and the blue distribution are different, right? They are. Mode is less pronounced, there's way too much positive, and there's not enough of the negative, right? So what you then can do, right, essentially this is a model that predicts, if you assume a certain benchmark damage, what will the distribution of the social cost of carbon look like, right? And it's a statistical model, so it comes with confidence bounds and everything. So if we run the blue distribution through that and compare it to the red distribution, the following emerges. And what we're looking at is, because it's easier to read, now looking not at the PDF but at a CDF, the cumulative density function of the social cost of carbon. In red, we're looking at what does the... No, I actually switched the definition of blue and red, I see now. In blue, we're looking at what does the literature on the social cost of carbon assume about the impacts of climate change. In red, we're looking at what does the impact literature actually assume about this number. Now, presumably the impact literature knows this better than the derivative literature, right? Now the difference doesn't seem to be that large, right? But, and that is what we show here in green, it is statistically significant. at least in the middle of the distribution. There are bits that are grayed out, the left tail and the right tail, because the uncertainty explodes, is not statistically significant, but in the middle of the distribution it is. And it seems that the social cost of carbon has been too optimistic about what is the impact of climate change compared to the literature on the impact of climate change, right? So let's continue the story, right? I talked about this first partial derivative. Now let's talk about this aggregation over regions instead. Now I showed you the picture of what happens to the average welfare on the planet. It's not particularly interesting because, I mean, nobody lives at the average anyway, right? If we look at the distribution of impacts across the world, the following picture emerges. So this is actually the same data that I showed you before. This, the 40 papers, a number of which have also regional estimates that you can then use to impute what are the national numbers. Some studies actually do present national numbers. So it's the same data set, but now, and still we have the Higgs equivalent variation on the vertical axis. On the horizontal axis we now have per capita income in the year 2015. And what you see is that poorer countries are much more vulnerable to climate change than the richer countries. One thing that I'll come back to later is I showed you that the actual the mode of the world average for 2.5 degrees is around -2%, right? You may wonder naively, how can this add up to -2%? The reason is that the world economy is concentrated here, right? There's lots of people here, but not a lot of money, right? So if we just add up dollar numbers, then we're going to skew towards this end, right? And that is what is done in most of these estimates. It's essentially $1, one vote, right? Not one person, one vote, or one country, one vote. No, it's $1, one vote. Now, why do we see this pattern here? Why are poorer countries more vulnerable to climate change? 3 basic reasons. One is the structure of the economy. We work in offices. 70% of the workforce in South Asia and Africa are farmers, work on the land, right? 50% of the economy in the poorest countries, 70% of the workforce. So they're simply more exposed to weather and climate. We hide behind walls and windows and air conditioning and heaters, right? So that is the first reason. Second reason, I'm going to replace the horizontal axis with the current temperature. Now what you see is that the negative impacts are concentrated in hot countries, currently hot countries, and actually the colder countries mostly see positive impacts. Exactly what you would expect. The plants and animals that we rely on are closer to the biophysical limits in places where it's very hot. Also, adaptation is much easier if you live in a colder place. If you wonder what will climate change do to Barcelona, you wonder what will the world be like if it's 3 degrees warmer, then you need to look like a place like Cairo and how do they cope with the heat, right? If you live in the hottest city in the world, Dar es Salaam, Jacobabad, Singapore, and you wonder what will a 3 degrees warmer world be like, you would have to invent the changes in behavior, the changes in culture, the changes in technology, the changes in building materials, and so on and so forth. You will have to invent that from scratch, which is much harder than copying it from somebody else, right? So that is the second reason why poorer countries are more vulnerable to climate change than colder countries. And of course, poorer countries tend to be hotter and hotter countries tend to be poorer, right? And the third reason is again adaptation. But now the social, the public part of adaptation, a lot of adaptation is private, right? If it gets warmer, you put on different clothes, right? You don't go running at midday, but you go running early in the morning, right? Those are decisions that you make for yourself. But a lot of adaptation is also public. If we're talking about protecting our coast from sea level rise, then in most countries we look to the government to build dikes and buoys and seawalls and those sort of things. If we solve our agricultural problems by expanding irrigation, we typically look to the government to provide the big canals and reservoirs. Also, if you look at healthcare, a lot of it is, rightfully or wrongly, in the public domain, right? Now, if you are in a country where the government doesn't know how to collect taxes, or if you are in a country where there's no qualified engineers or hardly any qualified engineers or project managers, then you can't build those dikes, right? Because that is actually a difficult thing to do and a costly thing to do. If you are in a sort of place where the government may be able to collect taxes, but those taxes disappear into Swiss bank accounts or London villas, then you can't afford those things. Or if you are in a country where the government simply doesn't care about you, then also you see a lack of provision of the public part of adaptation, and that implies, because what is known in the literature as low adaptive capacity is both a symptom and a cause of underdevelopment, and that explains also why poorer countries are more vulnerable to climate change than richer countries, right? Now, this is what the pattern looks like. You can't recognize countries here because everything is blue. You can recognize countries here because now I did away with the confidence intervals, but now I show the countries. The size of the bubble is the size of the population of the country. So obviously this is India, this is China, this is the United States. Right now you can recognize where countries are. There's one thing that confuses people, and that is that the social cost of carbon, although it is a first partial derivative, it's actually an absolute number. That is, if there's more people, a larger economy that is affected by climate change, then the social cost of carbon is larger, right? So if we are not interested in the social cost of carbon for the world as a whole, but only in the social cost of carbon for individual countries, then the size of the country actually matters, right? Matters even. That is shown in this particular graph. This is the national cost of carbon. So this is the damage done if we emit 1 additional ton of CO2 to India, to China, right? And this is not all countries in the world, obviously this is the top 25. And this is because the social cost of carbon is an absolute number. So bigger countries, bigger economies are more heavily affected simply because they're bigger. Not relative to the size of the economy, but just because it's an absolute number, right? So India and China come top. Then one thing that may surprise you, Ethiopia, Bangladesh, Pakistan, Indonesia come in places 2 to 6. The Democratic Republic of the Congo, and then Nigeria. These are actually fairly sizable countries in terms of the number of people. Right? We're talking about hundreds of millions of people. But recall that development pattern that I showed you and its relationship with the impact of climate change. These are the countries that are large and poor, right? So they are the ones that get hit the hardest. And the United States, which is also a very large economy, and therefore there's a lot of damage that can be done in absolute terms, actually comes only at place 23 in the ranking of the social cost of carbon. Right? And it's really dominated by the big developing countries. Of course, these countries are also at the top, particularly Ethiopia and Pakistan, because they also have still a very rapidly growing population. Right? It's not the current population that matters, it's the future population that matters. Final thing I want to say about this The scale actually runs here to $7 per ton of carbon. The global total is around 24, maybe 30, depending on how you discount. If we're running climate policy as a non-cooperative game, that is, each country taxes its emissions to the extent that it does damage to itself, then instead of imposing the global cooperative tax of 24, the max you can see is a tax of 6 or 7 in a place like China, right? And if the US were to impose a tax that is strictly in itself, a carbon tax that is strictly in its self-interest, it would be 20 cents rather than $20. So this is the public good nature of greenhouse gas emission reduction, right? If each country were to act in its self-interest, then the carbon taxes would be much, much lower. I'm now going to talk for a while about these two things. I'm mostly going to talk about time preference. Because it's terribly important, because we are talking about future damages essentially. And I'm going to rely heavily on what is known as the Ramsey rule of discount. Patrice Chérier and I forget his first name, Garcia Duarte, have last week, the week before, published a paper where they actually showed that Ramsey had nothing to do with the rule that is named after him. And it was really Canaro and Mordecai Kurtz who defined the Ramsey rule of discount. But if we assume a CRA utility function and we are in a sort of a dynamic equilibrium, then the money rate of discounts, the interest rate R, is equal to the pure rate of time preference plus the curvature of the utility function times the growth rate of consumption. And this has become a standard way of thinking about discounting in the long run, right? That if we want to know how much should we discount future losses that are measured in euros or in dollars, really what we need to know is the elasticity of intertemporal substitution, or rather its inverse, eta. We need to know the growth rate of consumption, and we need to know what we mean by consumption. And there's very little discussion about this. There's a lot of discussion about this, and there's an enormous amount of discussion about this rho, which is essentially a measure of myopia. How much do we care about the future because it is the future, right? This is pure time preference. It is known in the literature as the pure rate of time preference, but it's actually the rate of pure time preference, right? The purity is in the time preference, not in its rate. Now, this obviously matters. If you go back to my contour regression of the social cost of carbon on the assumption on the pure rate of time preference, then you see the lower the pure rate of time preference, the greater the social cost of carbon. And again, it's mostly the right tail that fattens. Similarly, if we look at the assumed elasticity of marginal utility, literature is a bit more confused about this, and it has multiple roles, but in the middle of the distribution you definitely see that the lower your eta, the greater the social cost of carbon, right? Now what's happening in the tails is mostly insignificant, but in the middle of the distribution you see that it matters. So then the question becomes, what is our eta and what is our rho, right? It's a very hard question. Actually, if you read through the relevant literature on this and you want to read all the literature, you need to go back to Aristotle, right? Because he was the first to write about this. And basically all major philosophers and a great many economists have written about it. But if you look at the social cost of carbon, and where do these estimates originate from? then this pattern emerges. This is again from the meta-analysis of the social cost of carbon. And what we see is that 46% of this literature originates in the United States, 20% in the United Kingdom, another 8% is from Germany, and then a bunch of smaller countries. China is a smaller country. Spain is there as well, less than 1%, right? I forget who it was in Spain. I know. It is the Joint Research Center in Sevilla. That's where the estimates come from. So it's Juan Carlos Iscan. Is the blue, right? Now this is a peculiar distribution of authorship, right? Not so much that we have this dominance of the United States. That is true for most of economics, not quite 46%, by the way. But there is hardly any representation of the rest of the world. I mean, Ireland is bigger than China. That's weird, right? If you think that the social cost of carbon is a recommendation of what the global carbon tax should be, and this is something that you want to push through policy, then the Chinese Communist Party is not going to be impressed by, well, 46% of our estimates are from a country that considers you to be the enemy, right? That is not going to convince them. So this is, from a purely perspective of social and political acceptability, this is the wrong distribution, right? But is it also wrong in the sense that the numbers would be different? Now, if we go back to the positive aspects of the social cost of carbon, like how much does the world warm if we put more CO2 in the atmosphere, if we double the atmospheric concentration of CO2, and it doesn't really matter whether you ask a scientist from the United States or from Japan or from China or from Nigeria, they would come up with the same answer. Or they would have genuine reasons to have slightly different answers, but they were looking at the same thing and they would agree on the methods to actually establish who is right and who is wrong, right? That is not something that depends on on culture. But those normative parameters, they do, right? And the two normative parameters that I'm going to talk about are the rho and the eta. A few years ago, Richard Tol and colleagues, 6 years ago now, surveyed some 200 economists on what the rho and the eta should be. And this is the range of answers that they got. Most of them say, well, the social cost of carbon should be fairly, the pure rate of time preference should be fairly low. Opinions are a little bit more spread on the elasticity of the marginal utility of consumption. Some say utility function is linear. No, Bernoulli. Most sort of say, well, a logarithmic utility function is fine by me, right? But you see a range of opinions there. The problem here is that of those 200 economists, only 8 are based outside of Western Europe and the United States and Canada. And they're all economists. And it's actually the literature is a little bit unclear whether economists are strange when they go into an economics education or whether they're strange when they come out of an economics education. There's actually, opinions are divided on that. But it is clear that trained economists have very different opinions about a lot of things than the general public, right? And these are parameters of the welfare function, right? And we are trained economists, so we understand what these things mean, but that does not imply that our opinion is more important than the opinion of other people about ethical issues, right? That goes against anything that we stand for in terms of democracy, right? We are just citizens in this regard, we're not. We are experts in the sense that we know exactly what these numbers mean, but that does not mean that our opinion about these matters is more important than the opinion of other people. So that is what Moritz did. Armin Falk, that guy I know, has also done some good things. And one of the things that they did was they surveyed some 80,000 normal people across the world in 76 countries, around 1,000 per country, apart from a few bigger countries where they interviewed 2,000 people, and they surveyed them on roughly the same questions about patients and about risk aversion. And this is the map, and apologies for the Mercator projection, they did that, not me. This is the pattern of their index of patients, and I'll show you the exact questions in a couple of slides. And what you see is that there are clear regional differences between how patient people are, right? And if you realize that the literature on social cost of carbon and drop survey comes from these blue parts, then you can say, well, these people were perhaps not representative, right? Similarly, if we look at the Falk measure of risk aversion, then you see also clear differences. The US sort of disappears, it's partly the projection is light blue. It's not that there's no data, it's essentially very light blue. So, what did we do? We took this, and then we calibrated it to these two distributions, because Falk does not come up with a pure rate of time preference, because you cannot ask the average sponsor on the street what is your pure rate of time preference, because it's a meaningless question, right? So we calibrated the two, and then the following picture emerges. So we took a standard, more or less standard integrated assessment model. So we have a standard carbon cycle model, we have a standard climate model, we have a standard growth model for the economy, and then we have Nordhaus's additions to this, and then we put in a little bit of shelling that richer people are less vulnerable to climate change than are poorer people, right? So that is the model. It's essentially dice with an ecomelasticity added to it, and we ran it through a standard scenario. Then in the green line that you see, we have the social cost of carbon according to the preferences of the 200 experts that were interviewed by Moritz Drop, right? And then this is the CDF of their numbers, this is cumulative density, this is social cost of carbon measured in dollars per ton of C. Then in blue, we did the same exercise, but now with the 76 countries that are in the Falk survey, right? And what you see is a shift to the left. So if you just focus on the median, it goes from around $28 per ton of carbon to around $10 per ton of carbon. You also see that the right tail swings, right? Which suggests that the preferences that go into this literature are perhaps the wrong preferences. Now there's two alternative calibrations that you see here. The blue line is essentially one country, one vote, the UN system. In orange we reweighted the country's vote by the size of the population, and then we shift further to the left. In yellow, we restricted our calibration to the same set of countries that are in both surveys. And then you actually see that we more or less mimic the gray line. That is, the difference is not so much between economists versus non-economists. The difference really is the West versus the rest, right? So it seems to be that when trying to estimate social cost of carbon, us Westerners are trying to impose our preferences on the rest of the world. Now, that paper is published in Economic Letters, and then when we're done, one of my co-authors said, we have the 80,000 answers. We don't just have the country averages, we have the 80,000. Why don't we run the model 80,000 times? I laughed at him, and it turned out that that was wrong, because our computers are fast enough to run the model indeed 80,000 times, right? So that is what I'm going to do next. Again, we see differences between people in different parts of the world. Here's China versus the US, and here are the actual questions that Falk asked. And he asked two questions, right? One is a very generic, qualitative question. And this is the version in English. How willing are you to give up something that is beneficial for you today in order to benefit more from that in the future? Right? Time preference, it's sort of very vague, generic sense, and then you answer it on a like it scale, right? They also put people through an exicotomous choice. That is, you were asked first, would you rather have 100 euros today or 110 euros in the future, a year from now? Then when you say, give me 100 euros today, then you were asked a follow-up question, 100 versus 125 in a year from now, right? Until you, and they did that 5 times, that is why if you know your Greek, it's exicotomous choice. And if you ask sort of like this decision tree in a sort of a nested way 5 times, then you actually get to a very narrow estimate of somebody's interest rate, discount rate, right? So that is what they did. And then they, instead of releasing the full results, they only released their index that they created with that. And here is the CDF of that index for the 2,000 people in China and the 2,000 people in the United States. And what you see is that the tails are basically the same, but in the middle of the distribution, US people seem to be more patient than people from China. Right? Similarly for the measure of risk. So a generic question, generally speaking, are you a person who is willing to take risks or do you try to avoid risks? And then again a decision tree type of question where people had to choose between 2 lotteries that are more or less risky. Right? And again what you see now more in the lower end of the distribution, that people in China give different answers than people in the United States. Right? If we run this through our integrated assessment model for all 80,000 people that answered, the following emerges. So this is for the world as a whole. It's for the US, and you see again a shift to the right. That is, people in the US prefer a higher social cost of carbon than people in the world, and China lies somewhere in between the two. Right? But we can do more than this, right? So far I've been using exponential discounting. Exponential discounting was introduced by Samuelson in 1938 and later axiomatized by Diamonds, Koopmans and Lancaster. And that is sort of like, for the older people in the room, this is how we were educated, this is discounting, right? Younger people in the room and the behavioral economists, no, well, this is not how people think, right? So exponential discounting has great mathematical properties, but it's just not how people discount the future. And most people have some form of what they can be called hyperbolic discounting. And there's many alternatives to exponential discounting that have been proposed in the literature. What we're going to do here is follow the late great Marty Weitzman and his proposals for gamma discounting. Now, how does this work intuitively? Suppose that we have a population and they are split 50-50. 1/2 of the population says the discount rate should be 1%, and the other half of the population says the discount rate should be 7%, right? Now, how would you do that in a democratic society? Well, the obvious thing to do is here we have the discount rate, right? Here we have the 7% discount rate, here we have the 1% discount rate. The obvious thing to do that would sort of come natural is to split the difference, right? And use an average of 4%. Now Weizmann realized that this is actually maybe natural, but it's wrong. Because what matters in your welfare calculations is not the discount rate, it's the discount factor. We don't multiply future utility by rho, we multiply it by 1 over 1 plus rho to the power t. Right? It's the discount factor that enters into our utility, into our intertemporal welfare function. So on a logarithmic scale on that axis, this is the 1% discount rate, and this is the discount factor that corresponds to the 1% discount rate. This is the discount factor that corresponds to the 7% discount rate. It's a logarithmic scale, right? That's why the lines are straight, and that is why you see this enormous difference between the two already after 65 years. Here we split the difference on the discount rate. In blue, we split the difference on the discount factor. And what you see is if you do it like this, and this is essentially what Weizmann proposed, is that you start off by roughly being parallel to a 4% discount rate, where you split the difference on the discount rate, and you end up roughly parallel to the lowest discount rate in your sample, the 1%, right? Now Weizmann has an earlier paper where he shows that if you actually project this into infinity, at eternity the two actually become truly parallel. It's not an optical illusion, they are truly parallel. Now what is the intuition between this? What's the intuition behind this, right? Essentially the people with a high discount rate, they don't care anymore about things that happen 100 years into the future. Whereas people with a low discount rate, they still care. And if you take the average of people who care and people who don't care, and you want to be fair, then you should look after the people who care. Because the people who don't care, right? What you do. Right? So, sort of if you think of this in terms of allocation over people rather than over time, if you have a piece of chocolate and you have two kids looking at you, how are you going to split the chocolate? You're going to cut it in half, right? You're going to give both of them half. But then when one of the kids says, well, I don't like chocolate, then you give all of the chocolate to the other child, right? Similarly for time preferences, these people don't care, right? So why would we put any weight on their opinion, right? They don't care, right? So essentially what you do in Weizmann type discounting is in the beginning you listen to everybody, but as time progresses you put more and more weight on the opinion of the more patient ones, right? And then at eternity you only listen to the most patient person in your sample. So what does that do to the social cost of carbon? Right? Rather than look at the mean, rather than look at the middle of the distribution, really we should be listening to the people at the right end of the distribution. Right? That is essentially what Weizmann says. And the result is exactly as you would expect. So in blue, for the 76 countries in the Folk survey, we're looking at the social cost of carbon when estimated with the average preferences of the people in that country. And then in blue plus orange, we calculate the social cost of carbon for each individual according to their preferences, and then average over the country, right? And the difference between the total and the blue we call the Weizmann premium in honor of Marty. And what you can see in this graph is that the Weizmann premium is enormous, right? This adds a lot to the social cost of carbon. This is for the 76 countries. Here we're looking at the global total. This is always a bit tricky. So first, one person, one vote. Full direct democracy worldwide, right? Some people like that. If we use the average social cost of carbon for the average preferences for the world as a whole, the social cost of carbon would be $5.4 per ton of carbon. If we use the individual social cost of carbon and then average, we find the social cost of carbon of 30.5, sorry, and the Weizmann premium is then 25.1, right? Or we add 77% to the social cost of carbon. This is a big number, right? Now that is one way of aggregating opinions, right? Here we first add up to the country and then give each country one vote, right? The United Nations system. Here we do what is actually most common in the literature. We use $1, one vote. We first aggregate to the country and then weigh the country by the size of their economies rather than the size of their population. And here we use so-called equity weights, where we correct for the fact that $1 to a poor woman is not the same as $1 to a rich woman. That obviously matters for the totals. The Weizmann premium is very large regardless of how we aggregate to the world, right? When I gave this talk 2 weeks ago, I think, people said, well, you have 4 ways of aggregating here. I can think of 7 more, and no doubt you can as well, right? But this is the 4 that are in the draft version of the paper. We also did a whole bunch of sensitivity analysis around this. I should not do that. Scenarios matter, but the Weizmann premium is pretty big. The way we calibrate the fall preferences to the drop preferences matter, but the Weizmann premium is very big. But we assume the shape of the utility function to be matters. Matters quite a lot. In some cases, the Weizmann premium really goes through the roof. There's one proposal in the literature that the utility function, the impact function is a bilinear function, that is, it goes up and then down, rather than as a parabola, it just goes up straight and straight down. Of course, if you have a linear impact function, then your first partial derivative is a constant. And on the one side of the bilinear, you have a lot of damages in the near term, so the people with a very high discount rate think this is very important. But then you also have lots of damages in the far future, and the people with a low discount rate think that is very important. So this one sort of gets hit twice by the Weizmann premium, right? That is why it is so very, very large. The thing that I want to draw your attention to mostly is this thing here. This is the assumed income elasticity of the impacts of climate change. So I showed you this graph where poorer countries are more vulnerable to climate change than the richer countries. And if we project that into the future, richer people will be less vulnerable to climate change than current poorer people. And the literature on the impact of natural disasters suggests that this income elasticity is around 0.36, and that is the number that goes into here. That's our base case. If we reduce that to 0, and that is Nordhaus's assumption, then the social cost of carbon goes up, and goes up quite considerably. The Weizmann premium also goes up. So this particular parameter also matters quite a lot. And there's a lot of discussion, a lot of confusion in the literature about what this number should be. That's why there is this range of numbers that you see here. There's also people who actually make it smaller than -1. And then there's a few clowns that think that this number is actually, its income elasticity is positive. That is, the richer you are, the less likely you are to buy bed nets for your children to protect them against malaria, or the worse your ability to build dikes become. It's a completely bizarre assumption, but you can find it in reputable journals like the American Economic Review. And this parameter matters, right? This parameter matters. Now, a few more minutes left, right? As I said, Falk did not release all his data. He did release some data, and one thing he did release was the age of his respondents. So we can also do this not just for countries, we can also do this by age, not just group, by age. In orange, you're looking at the pure rate of time preference, and what you can see is that it's basically constant until you hit retirement, and then people become more impatient. During their lifetime, people actually become more and more risk averse. If you put the two together, then actually what you find is that the social cost of carbon is higher for younger people and declines towards for older people, right? And this is a pattern that we see in survey after survey after survey, that younger people care more about climate change than do older people. And according to our estimate, it actually they advocate for a higher social cost of carbon, and the difference is significant if you compare the youngest cohorts to the oldest cohorts. That sort of like roughly validates what we found. So to round up this particular part, I actually gave you two messages here, right? The majority of people prefer a higher discount rate than Western experts, and so a lower social cost of carbon. But then, if we actually don't look at averages, but actually look at the average of the social cost of carbon, if we shift if we change the order of the operators, the average social cost of carbon is much larger than the social cost of carbon for average preferences, right? So I've argued both for a higher and a lower social cost of carbon. So to wrap up the entire talk, social cost of carbon is a key parameter in the economic analysis of climate policy. There is a large literature that constrains the policy advice only somewhat. If somebody says that the social cost of carbon is less than $10, then I would say, well, no, you're really an outlier here. If somebody says it should be $1,000, then I would say give a similar message. But I think it's very difficult to say whether the number is 20 or 200 or 400, right? I think credible assumptions would give you that range of results, right? Recent estimates are higher, not so much because we care more about climate change than we used to. That is not the case, not because our projections of climate policy, of climate change have become worse over the years. That is not true. It's mostly because people are using a lower discount rate than they used to, and people are throwing in risk aversion and ambiguity aversion and all that sort of jazz, and that is driving up the social cost of carbon rather than a change in the underlying concern about climate change. And really the take-home message here is that this is a literature that is still growing very rapidly because we don't have proper constraints on this, and actually I don't think there can be proper constraints on this because the social cost of carbon depends on positive parameters that are actually often very hard to measure. And I gave you the example just a minute ago about the elasticity of the vulnerability to climate change, the income elasticity of the vulnerability to climate change. There's a number, actually no clue what that really should be, right? But it is very important. And then there are these normative assumptions where the pure rate of time preference we have been debating since Aristotle about what its number should be, right? And there's no reason to assume that that debate will settle anytime soon, if indeed ever. That's all I wanted to say. Thank you for your attention.
Thank you, Richard, for this interesting talk. Now we have several minutes for questions. Do you have any question? I think you need the microphone.
I can hear you, but we're being recorded as well.
For the recording.
Thank you very much for the inspiring presentation. I have a general
Can you
question.
stand up?
Yes.
I'll come closer so that
I have
can
a
hear the
general
question.
question. The analysis that you presented mostly considers country level, and you talked about total welfare and global welfare. But if we consider a specific society, who exactly in your opinion bears the cost of emissions within the societies from microeconomic perspective, and how we can ensure social justice within a society, not to make vulnerable people pay for the consumption of richer people. Thank you.
So the question is, you talked about the distribution between countries. What about the distribution within countries? I went over this one pretty quickly, where do the numbers come from. There are some observations, but there's a lot of imputation going on here, where essentially, I mean, some of these studies sort of like estimate the impact for 9 different regions, right? And that then implies an income elasticity that you then use to project for 200 countries, right? That's pretty hairy, right? There's no reason to assume that the same pattern would not hold within countries. But there is basically no empirical evidence. So there are 2, maybe 3 papers out there that essentially use the same method, like we have an income elasticity of this vulnerability, and then we're going to project to income classes within a country. Well, there's 4 or 5 papers, sorry, I forget one. Or we're going to project to administered regions, so the provinces of Spain rather than Spain as a whole. There's papers that do that, but 99% of those results are imputation rather than observation, right? And then you find, yes, indeed, poorer people are assumed to be more vulnerable than richer people. Mechanically, it's easy to do. I would not put a whole lot of credence in those estimates. There's no reason to assume that what you say is not true, but we just don't have the numbers to do this properly. One thing I did not say. This pattern, of course, implies 2 things. One, you have much, I should stay with the mic. One, you have much greater vulnerability to climate change in poorer countries than in richer countries. That is one thing, and that is a concern for climate change. That is a reason to cut your greenhouse gas emissions. But I also said, well, this is actually a symptom of underdevelopment and a symptom of mismanagement. So this is another way you can counter these things, and that is to grow faster and develop faster. Then you would take away a lot of these very negative impacts. Now that is true between countries, it's also true within countries. And within countries it's actually easier to redistribute income, to have policies that particularly target the poorer people, particularly protect them, and so on and so forth. But if you take Bangladesh, for instance, the big issue in Bangladesh are the typhoons, right? The tropical storms that bring a lot of water and also bring a lot of winds, enormously damaging. But what they have done since the 1970s is build these shelters so that, yes, your hut is blown away or washed away, but at least you and your family survive, right? And those are policies that specifically target the poorest in Bangladesh. So there are definite programs that you can do to protect people. One of the things that has been happening in Europe since the 2003 a heat wave in France that killed 43,000 people, is that many European countries now have heat wave plans. And part of the heat wave plans in Europe, the big issue with heat waves is essentially that older people, very young people, people with cardiovascular or respiratory problems succumb to the heat, right? Essentially, if you don't treat it fast enough, you die. A lot of countries in Europe have now sort of created these cool banks, where it used to be that if you were poor, you could not afford air conditioning. Where did you go when it was very hot? You went to the mall, right? Because that was air conditioned, and then the security guard kicked you out, right? Because you were not buying anything, you were just sitting there. Now that is allowed, right? So that, and there's actually dedicated cooling centers for those who cannot afford air conditioning in their home. Then they can go to a place somewhere in the municipality where there is air conditioning, and they can spend the heat of the day there, right? So there are definite things you can do to help the poorest, but of course it depends strongly from what impact are you talking about and how to best do it, and of course what is the best way of organizing these things in a society, right? And that differs very strongly from place to place. Long answer for a shorter question.
Another question?
Go ahead.
I have a question regarding the hundreds of studies on social cost of carbon. To my knowledge, there's still in the literature and in the modeling community a difference between like the mitigation models and the adaptation models, and they do not largely interact with each other. So like damages occurring through increased temperature will lead to like extreme weather events, will lead to like damages in the economy, will lead to financial instability and so on. But this does not translate into the mitigation models where like energy system optimizations due to kind of policies will occur. So I'm just wondering how much are you also taking this into account, or is this already been addressed in the social cost of carbon literature, that these systems are quite like isolated to each other?
That's a good question, and the answer is a sorry answer. In the early days, integrated assessment models were integrated, right? Steve Mack and Tom Theisberg wrote the first integrated assessment model. Nordhaus was actually the second. And there was impacts of climate change, there were impacts of climate policy, and these were cost-benefit analysis, and they did both, right? But as academics, we need to specialize. And unfortunately, what we've seen the last 20 years or so is that these models have diverged. There are now models that focus most of their effort on climate policy. We have models that focus most of their efforts on the impacts of climate change, right? And whereas it used to be that these two groups regularly talk to each other, although they disagreed about what is the right strategy forward, that communication also has largely broken down. There are still a fair number of models in the Nordhaus tradition that sort of like do both, but the models that do both actually use very simple representations of either climate policy or climate change, right? So that is unfortunate, but it comes from the need to specialize, right? If you want to make an impression on peer reviewers, you need to do something new and fancy. And doing something new and fancy in a complicated model on both sides of the equation is actually too much for a single paper. 20 years ago, it's now too much for a single career, I would think, for younger people. So that is unfortunate. Now, there is a positive side to this, and that is Chris Boehringer and Tom Rutherford had a paper in 1997, if I'm not mistaken, where they actually show that the two questions are by and large separated. That really the social cost of carbon is a sufficient statistic for what is going on if you're doing climate policy. Whereas if you're doing the impacts of climate change, then the carbon tax is actually a sufficient statistic for what is going on in climate policy, right? So you don't need the full-blown model on both sides. Now that was true in 1997 in their paper, but if you now think that actually a lot of the impacts of climate change come through energy use, and actually there's also impacts of climate change on energy supply, right? Not just hydro, not just wind and solar, but also if it's warmer, then you can't transmit electricity in the same way as when it's cooler, right? Temperature actually affects the transmission of electricity, increases the resistance of your wires. So there are subtle interactions. And of course, more and more of our climate policy is now focusing on agriculture, which of course also is heavily affected by climate change, right? So yes, there is a reason to now say we should go back to the olden days where we actually built integrated assessment models that were truly integrated in that they looked at both sides of the cost-benefit equation. But these communities are now largely divorced, unfortunately. So it will take a while before we're there again. There's a few brave souls that are still trying, but not really succeeding.
We have 2 minutes for another question, a last question. Are any last comment or question? I myself have one question. Okay. According to the last conclusion, could you say more about the ability to estimate carbon tax and internalize the externality? Could you say a little bit more? What do you think, in your opinion? So this is the history of a failure. What can we expect in the
Europe?
future? Yes.
Well, in Europe we have the emissions trading system, right? That puts a price on carbon, which is a good thing. Of course, if you think back on another piece of work that Weizmann did, prices versus quantities, and then the extension of that by Billy Peiser and colleagues to a problem like climatic change, that if you have a stock pollutant, then really you should focus on a price instrument rather than a quantity instrument, right? It is fairly well established in the literature that the European Union picked the wrong instrument for this problem. The reason that the EU did this is very simple. This was discussed in the late 1990s, in the early 2000s, where the idea of tax harmonization across the EU was just a non-starter, right? At that time it was actually the UK, still a member of the EU at that time, said no to just the idea of discussing even tax harmonization across the European Union. And other countries like Ireland basically agreed and were sort of like happily hiding behind the UK, opposing this particular policy proposal. In the current EU, of course, the UK is gone. Ireland is still dead against tax harmonization. Also, the Baltic countries that are now members of the EU, no to tax harmonization. It's just a political non-starter. To hand this particular power from Madrid to Brussels, no way, it's not going to happen, right? So that means that the EU is stuck with its emissions trading system. ETS started pretty poorly, but it's getting better and better over time. They're slowly sort of like molding it to work better. It's expanding. It started with 40% of CO2 emissions. It now covers 60% of greenhouse gas emissions, right? Nitrogen is in there, other bit of methane is in there. They made a strategic mistake, I think, when they brought in aviation, to rather than bring aviation into the ETS, they set up a separate ETS for aviation. And now they're bringing in transport emissions, and they're bringing home heating into the EU ETS, but not really. They're setting up a third market of permits for these things. It's not perfect what they're doing, but gradually carbon pricing is expanding in Europe. It's covering more and more of emissions. And there is some fungibility between the two markets that are already there, and hopefully with the third market that they're now putting together. And then we have a more or less uniform price of CO2, just as Bommel said we should. Importantly, with the introduction of the carbon border adjustment mechanism, we're also now doing away with that stupid thing that we never should have done, and that is give away permits for free. A larger and larger share of permits are now auctioned, and that means that the carbon permit market is now almost like the carbon tax as it should be. In many ways it is the same, right? So yeah, the EU is gradually getting its act together on how to do climate policy. So I'm reasonably hopeful there that in 10 years time we will have an almost first best, or at least this part of climate policy is almost first best, right? We still have double regulation and subsidies and mandates on top of that, but those are also becoming less and less important. So we're moving towards where we want to be. It took a while, but that is mostly political constraints that did not. I mean, if you talk to the civil servants, the bureaucrats in Brussels, they actually know how to regulate CO2 and other greenhouse gases. They are very well qualified and well trained economists, and it's mostly political constraints that prevent them from doing the first best. But they're gradually moving the system into where it should be, right?
Okay, so let's finish with this optimistic message. Thank you, Richard.